Hello everyone. Today I'm going to show you something about my master degree thesis. So I am going to give an overview like how I perform my master thesis. So it will help for you to work in this kind of things. So my master thesis topic is deep learning for photovoltaic potential, evaluation of an alternative approach for the roof segmentation and orientation determination. So we will go forward. So I have divided this presentation into some 7 parts. So first of all, we are going to talk about the introduction and motivation. So in Germany, 59.8 gigawatt of the solar power has been installed by the year of 2021. So uh, it has sharply increased to 63.62 gigawatt at the end of September 2022. So it shows that there is sharp increase in the solar power potential. Also might be due to the war going on between the Russia and Ukraine. So drawbacks of the existing approach in the what I am trying to say will be further described, but manual work and data driven approach are done for finding the total solar power potential. Yeah, so for example, if you need to determine the solar potential of your roof of your house, you have to do the manual work or data driven approach, leader approach, but leader approach is too costly. So also for the stakeholder or for the administration, it is not possible to do the leader approach for every houses and manual work for every houses to find the total solar potential of a roof. So we are going to use um, satellite images on a large scale, um, which 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 would be used to find the solar potential of every roof that are present in the area. Okay, so our main research objective is to include all the previous studies has included all the parameters calculating the solar potential, and each per pixel solar power potential is calculated, and uh, um, adding all the per pixel solar potential will give the final solar potential. So we will these will be the different roofs. So different roof has different solar potential. So the altogether solar potential will be calculated in this way. But the problem is in the some of the roofs there, the some of the parts of the roof do not face the sunlight at any time, or it face the less sunlight like in the figure here, and sunlight will be facing some of the parts only. So what is the point of having this calculating the solar potential of all the roofs? Yeah, so it's not important to calculate this part while calculating the total solar potential. So this will make our result bad as a whole. Yeah, so we are trying to have a unique solution to find the orientation so that we can have a good overview. So in Germany, or in the European countries in the northern part, face more solar rays, solar sunlight than the other parts. So we have to keep in mind that one of the sides will receive more solar potential. So adding all the solar potential will be vague and it has no importance at all. So these are the things I have written here. So roof orientation should also be calculated. And in the previous studies, uh, from the TU Munich has defined 18 classes to derive one information, that is the solar roof orientation. That means all these 18 classes has been used for just finding one information, that means the solar orientation. If the roof orientation, like if the roof is facing northeast or east or west. For that we have to have different classes, because we are doing deep learning method. For that we have to label each of the images, each of the roof, each of the roof segment into different orientation, and it is so cumbersome. Yeah, like even from the um, images we cannot determine the exact orientation. First we have to label, and then we will um, go into the deep learning. So it will just segment the output uh, by using that model. But it takes 18 classes, and it needs too much labor, and it will be the costly method. Yeah. So our research objective one will be calculation of the azimuth and determination of the orientation of the roof using different class definition. So we are not going to use the 18 classes. Yeah, we are going to use 18 classes in later section, but now we are just going to use a different class definition. So what does that different class definition means? We are going to have a discussion on that in the further chapter. So RO2, our research objective 2, is the evaluation of the orientation result and compare to the previous approach. Yeah. So we have to compare, and if this approach is good and is less costly, we can have this approach rather than the previous approach, which considered 18 classes to derive one information. So talking about the first research objective, we have one and the research question, two research questions. What are the benefit of using different class definition over 16 orientation classes? So what I'm trying to do, how can it help, or how can it overcome the previous approach? And how can a roof line separate the roof into different roof segments? So what we are trying to do. So I'm not going to the second research question. Yeah. So I'm just going to discuss about the research objective one. So our main theme is research question two, main part. How can a roof line separate the roof into different roof segments? So we can see these are the related work. So I am not going to talk about this related work. So I will tell about my methodology. Yeah. So we will have the aerial images, which are the satellite images of the roofs of a specific area. I have taken the part of the small part of the Munich. So, and we have similarly the labeled image, which were labeled by the people at TUM, by the student at TUM. So we prepare the data, and uh, we separated this data into the training dataset, validation dataset, and the test dataset. As we know in deep learning or um, um, any model generation, we have to separate this data, and training dataset is used to train the model. So after that, we are going to validate the model. So it is a deep learning part. You can also see the deep learning things in other YouTube channels, but my main task is another thing. So my main task is this one. You can see here we have the leveling of the roof lines, which is these black lines, and the white lines is the roof, and these are the background. The outer line is the background. Yeah. So also we have some things. The center line are called cables. Yeah. And the outer, this line where the water, the rainwater will be collected, is known as gutter. Yeah. So for the first experiment, roof and roof lines levels images were combined. So roof and roof line images. Yeah. Here is roof and roof line. So this images is used for the training purpose. These images and this level images are used for the training purpose. And when the model is prepared, we can get the output as this image in the output. Yeah. So We have first splitted the data that is common in deep learning or any of the learning process, and we have used the unit model for the training. So this is the output. This is the aerial image which we have used. This is the image which is the ground truth image, which is the label image, which has been done manually. And the third one image you can see here. The third one image is the output image when the test images are applied. Okay, when the images are tested, when the test images are sent to the model, the output is this one. Yeah, so it we can see that it can clearly identify the roof and roof line. Yeah, here we can see the roofs are well segmented. That means we can use this data for um, our further study. So what we are going to do now in the methodology part 2 is we will have the predicted data set. That means we will have this data. We will have this output data. Yeah, because we you should understand that it is not feasible to label all the data. So we use deep learning model to segment the unknown or unlabeled data. So we are in this example, we can see if this is the unknown, if we input this image, the output will be this one. Okay, that's the thing. The model will know that this is gutter, this is roof, this is roof lines, and so on. So we have the predicted data set. So after that, we will do the image processing. In image processing, we have the segmentation of the roof segment and segmentation of the gutter. So roof segmentation of the roof segments means this roof segment we have segmented out, and then we have the segmentation of the gutter. And in this part, we have the vectorization. So we are going to convert that image into the vector form, and we will perform these activities. Minimum rotated rectangle, and we will find the nearest gutter. We will use the nearest gutter algorithm, extract the gutter line from the minimum rotated rectangle, and then azimuth calculation, orientation determination, and added the geoframe of all segment and display the orientation map. So we are going to show one by one. From this image, we do the image processing. Yeah. So we just remove this background roof line and equalize with the background. So we will have only the roof segment here, only the roofs. Yeah. In this, we just extract this information, which is gutter information, and we will just have this. We will equalize this background with these lines, all the lines except gutter. So we will have this line. Okay. After that, we will have the vectorization, which means the conversion of this image into the vector form using the OpenCV contour detection. Okay. So these images will have just a line after that. Yeah, it will be converted to the vector. And how would it form? It's like this. This zigzag line is the vector form of that image. Okay, and we have used first longest line algorithm. We thought that the first longest line will be the outer line. Okay, because in this roof we have to find orientation. Orientation could be found by using its longest line method, but we were wrong in this case. Yeah, because the roof can be of any type. So first what we did is we converted into the minimum rotated rectangle because its shape is like zigzag, so we created a rectangle out of it. Okay, so we will find the longest line from for this segment, we are finding the longest line. So both will be the longest line. Okay. So, but this algorithm will choose one of the line as the longest line randomly. So this algorithm is not good. Another method is farthest roof segment algorithm. So this algorithm also is also failed in the multiple roof segment and edge cases roof. So I'm not going to talk about it, but I'm going to talk about this nearest gutter algorithm. What we did is first we created the minimum rotated rectangle out of that vector form. Okay, and we also take that gutter information, the vector of that gutter, what we have talk about here, like we converted it into the vector form. So we take that gutter and we have roof segment and gutter. Yeah, so what we did is using the safely function, we found out that which is nearest to this line. Okay, or with this polygon, which line is nearest to this polygon, and this line will be because this line will be nearest to this polygon, because we have only two gutter in one house. Yeah, so this is the gutter, this is the gutter. So this line, this segment has this line, so this line will be the outer line of this house. So it will be considered the one of the factor for determining our orientation. So what is next? We are going to calculate the azimuth. So this is the one roof segment as shown here. This is the roof segment and this is the gutter. In a similar way, this is the roof segment, this is a gutter. So gutter is outer part. So we are going to find the angle from the north. Okay, so this angle will be um, some values from 0 to 360 degree. Okay, so after that, finding the azimuth, we are going to find the orientation by using this algorithm. So if it's greater than 348 or less than 11.5, it's not. If it's from this to this, not northeast. So we have this, we have determined these values. We have calculated the theta, and then we use that theta in here azimuth, and we have the table to convert. If the theta is in this range, we have not in this range, not northeast, and so on. So we determine the different classes by using these values. So after that, we have converted we have added that information of the background, this orientation in the geodata frame, and shown like in the figure. So this, when we click in this roof, we can see that it's southwest, and if we click this, we can see its values. So azimuth will be this value. So we can determine the azimuth and orientation by using this method. So this will be our output. So this is east, this is west, yeah, this is north, this is south. So we have the lesson 2. So what we have did in this thesis is we just use the three classes, basically the roof line and gutter, and we have found out 16 orientation from that information by labeling just things three things. We don't have to label every roof, every direction, or because in the previous study they have labeled every 16 classes, every roof is uh, labeled. For example, this is in the west side, so it was labeled as west. This is north, labeled as north, and then they use the data for the deep learning, but we just use basically the three information: roof, roof line, and gutter, and get the result in 16 different orientation form. Yeah. So we have this result and discussion for the network 8. We have the maximum high result. So these are the results we can see here. So this is the output, which is clearly nice. Yeah. And what I'm trying to show you is the confusion matrix also shows a good result. Our confusion matrix using the nearest cut algorithm shows a very nice good result. So we have also calculated the mean orientation error, but it was the result was not that much good because of the uh, differences between that mm, high. The difference is we cannot. There is still problem with the vertically opposite angle. So if it if it's east and it detects west, we have the angle difference of 180 degree. So while squaring that 180 degree, it will be too much. Yeah. So that was the problem in this finding the mean orientation error. So we have got plus minus 74.82 mean orientation error, but if we also reduce that error of 180 degree or 90 degree, we can reduce it more. So these are the comparison of the original data and our predicted data. So we can see they have the similar results. And also we can see, maybe I have used I have used my GitHub page. We can see the result here. Like it is east, it is west, it is north, it is south, it is north, south, south, west. Okay. In this way, we can also have the result. So what this result, what is the further things we should do is in this area. First, we should analyze which uh, direction or which orientation is good. Okay, which orientation is good for installing the solar panel. So we should just only select the orientation uh, visi- which are feasible for the um, calculating the potential, and skip the roofs which are not feasible. Okay. For example, if this eastern part is feasible, we just select the eastern part and just ignore the western part for the calculation of the total solar power potential. So in this way, I have completed my thesis so this is the final output, but still have to do some more things on the part of the um, determination of the photovoltaic potential, but that was not my part. I was just employed to work on this alternative approach. So I did my best to work on that. So hope you like this video. So if you have any questions regarding this, I am very happy to reply. Yeah. Okay. Bye bye.